So again, hello everyone. So today we are going to cover up the implementation part. So we have covered the theory part in our last lecture of the supervised learning, where we have taken the linear regression model and we understand the theory behind it based on our problem statement, right? Now, in this today's lecture, that what we will be covering the entire implementation part. What is implementation? The practical understanding of whatever the theory we have covered, right? We will be building the real life application to predict the blood glucose level of any patient. Okay, so we will do everything. So what I am expecting from you is that you should have a Google Colab account, right? What is Google Colab? So Google Colab is an interpreter where you write your code and implement it. That's it. Okay, I'm hoping that you know Python. Okay, I will be again starting it from the very basics and other things, right? So you don't have to worry. You just go and type Google Colab, right? Just go and type Google Colab in the Google, and then you just need to open it. Okay, and this interface will get opened, right? Now you just go to this runtime, go to this change runtime option, and then click the GPU. Okay, why GPU? Because you need a good processing power, right? That's it, simple. Okay, and then what you need to do next, you need to upload your data. I have already showed you in my previous lecture that this is how my medical data looks like, right? So in order to upload the data, there is a upload button here on the very left, top left corner. Just go and upload the data from your local directory. That's it, right? Now you need to follow this notebook entirely. Okay, so I'll be following this notebook in my upcoming lecture as well, so that you would get it right. Now let me start from the very basic, because what I am assuming that that you may not be aware about all these things. So I'm starting it from the very basics, right? So let's clear up. So these are the Pandas library. Okay, what is Pandas library? Pandas is a library, okay, in Python, so that you can do a lot of this data manipulation part. Again, before coming to our golden 9 rule steps, I want you to clear up some basics. That is why. Okay, so this is just a Pandas library. Just be with me for like next 18 to 20 minutes, and you will going to understand everything. So this is the Pandas library. Okay, and I am going to share this notebook to you. So what the first thing I am doing is that I am supposed to import this library. Okay, I am supposed to import this library. I will be running this function import pandas as pd. Okay, simple. I'll be running this Pandas library in order to read my data. Okay, how do I read my data? Simple, pd.read.csv. That's it, pd.read.csv. Now what this command will do is that whatever my data is present, right, whatever my patient data are, this data is already in Excel sheet, right? So in order to read this via Pandas, I will be running this command. Okay, pandas.read.csv, and if I just going to like save it in data object, so I will just supposed to run this, and you will see that every data is now in my collab system. Okay, no rocket science. Now the next step is, let's say, what does this if you want to see the first 5 row of the data, so you need to apply this command, which means data.head. Okay, what is data? Inside my data, all this Excel sheet raw data, okay, it is actually present in my now my data variable. Okay, so now in my data variable, if I just wanted to see the top 5 row, I will just like execute this command data.head. Okay, and then if I see the fives command, suppose if I just go and see, wanted to see the top 10 row, so inside the head I will just pass my parameter as 10, and I am able to see the first 10 row, okay, of my raw data. Okay, now suppose if you want to see the last 5 row, then what you're supposed to do, you're supposed to call data.tail. Okay, that's it, right? Now suppose if you want to see the shape, like the row and column of your entire data, of your raw data, how many number of rows and how many number of columns you have, just run this data.shape. So it will do is that your raw data is containing 768 number of record, okay, record of each patient, and then 9 column. Okay, so these are the column name. Okay, these are the column name, like pregnancies, glucose, blood pressures, just like this, right? Pregnancy, glucose, blood pressure, these are different columns, right, in Excel sheet. If you want to see it via command, we can actually run this. Okay, now let's move to the other thing, like what is data.describe. So in data.describe, you will able to see all the statistical description of the data. Okay, whatever your raw data is, you will see different things. Okay, so you will see that how many unique count it has. Okay, of each column. Okay, so if I am just like figuring out that if I need to check the glucose column, so I am able to see that, okay, like how many row it has. Okay, then what is the mean of each number, like the entire column. Okay, what is the mean, which means what is the average value. Okay, what is the standard deviation, what is the minimum number. Okay, what is the maximum number, what is the 25 percentile, 50 percentile, 75 percentile. Okay, these things we need, right? Then suppose that if you want to select any column, selecting column means what? See, this is my data, I want to select, let's say, BMI column. Then how would I do that? Via pandas coding. Just simple, very simple. Just data and then just write BMI, that's it. So you will able to see all this BMI data. Okay, so suppose if I want to see only a glucose column, I will write glucose. Okay, I hope the spelling is correct, GLUCOSE, right? So I am able to see the glucose column, that's it, right? Then suppose if I able to see, like if I want to see more than one column, I will just write in this format. Okay, more than one column name, that's it. So I will be able to see the multiple column, right? Then what is this 1.8? So it is like if I wanted to see that if there is actually any missing value. Okay, missing value in the column, I can able to like take the sum of it. Again, I am telling, see, from the very basic. So what I am able to do is that, let me first copy the path of my data which I have loaded, right? And then let me just paste it. Okay, so this is my data, right? All this data I have. Then let's say again, if I run the data describe, so all this data, then like if I wanted to see the glucose data, more than one column data, right? And if I want to see that how many missing value my one column contain. Okay, what is meaning missing value? See, you can see that if I pick this insulin column, right? So there are a lot of missing value, right? See, there are a lot of missing value. This is there, right? Then this is also there. See, this is like row number 91 of insulin column is also missing, right? So if I wanted to find out the number of missing column, what I supposed to run? Just this one, that's it. See this one, right? It means that glucose column has 35 such row which has missing, which does not contain any number. Okay, so yeah, these things you can able to get it, right? So these are just functions, or let's say most frequently used tool in the pandas, like which in the Python, right? Now let's look into this, and these are sufficient, like these are more than sufficient. Now similarly, let's look into this NumPy. Okay, so pandas is for like fetching the data and other things, right? NumPy is mostly used for, NumPy is also a Python libraries, but NumPy is basically used for like doing some operation with the data, that's it. Okay, so how do I actually import the NumPy? Simple, import NumPy as an NP. Then suppose that wherever, right, because I'm doing the operation, right, pandas was able to just see visually, like watching the data, right, what is present in the data and other things, like fetching the data from your Excel sheet, right? Now where this NumPy comes into picture? Okay, because NumPy is actually a tool, right, in Python. So where this NumPy come, like how do we supposed to use this NumPy? Whenever if we want to do some operation. Okay, whenever we want to do some operation, we are supposed to use this NumPy. Okay, now what operation we are doing? So I have just documented everything for you. Okay, the first operation is like replace the impossible zeros. It means wherever there was zero, right, I will be replacing it with null value. Simple. Okay, you can see that there are so many places there are zero, right? So I will be replacing this with null value, that's it. Okay, so if I just going to see that if my data, let's say data, right, so data, and then if I wanted to see this glucose, right, glucose, see, now all this zero part, right, has been replaced by null value. Okay, this nan value. Okay, and similarly, let's say if you want to replace this by, let's say if you want to calculate the median, right, if you want to calculate the median, you can actually calculate the median as well, right? So let's say, and what is this, what is this one, what is this? So this is like you wanted, like you want to drop such row. Okay, you want to drop such row which is actually empty. Okay, so you want to drop, let's say wherever there is a empty value, right, you want to drop such row, okay, from this column. Okay, so this is like the function of that thing. So in the glucose, I will be dropping this row, okay, in the glucose column wherever there is null value or wherever there is a no value. That's it, right? So this will able to drop these things. Okay, again, if I going to check this data.glucose, you would able to see this part, right? See, right? So it will able to drop any of these row, okay, which is actually containing the null value. Now this is what this is actually again finding out the median. Okay, now this is like finding out the median and like mean and standard deviation. Okay, so if you wanted to find out the mean and standard deviation of any of those column, you would able to see that thing. Suppose if I wanted to mean and standard deviation, I will be just using this np.mean and inside this column name, okay, let's say glucose. Okay, so if I wanted to find out the glucose like mean and standard deviation of the glucose column, you can able to find out. That's it. See, the mean of glucose, which means the average value of the entire glucose column, is 125.5, and similarly the standard deviation of the entire glucose column is 61. Okay, so this is like the pandas and numpy library. Okay, now what is matplotlib? Now let's have a quick handover on the libraries such as matplotlib. Okay, so matplotlib and Seaborn. Okay, so where does this use? So whenever you want to, let's say, do a data visualization thing, okay, let's say that you have this data and this data looks very raw, right? So let's say that if you want to visualize it properly, okay, you want to show someone a very valid sense of visualization to anyone. Okay, because anyone, if they see data, if they actually watch this data, right, it feels very boring, okay, and it looks very orthodox. I don't want that, right? So what I will do, I will just going to use these libraries. Again, these libraries are already in the Python function. What I'm supposed to do, again, I will be, what is pip here, I will be installing this Seaborn as a package, okay, from the Python, so that I can use it. Simple. Okay, then I will be importing this matplotlib and I would be importing the Seaborn. Okay, matplotlib, I am just giving a very small name as plt. Simple. So wherever I am supposed to use the matplotlib, rather I should use the plt. Okay, I am using the abbreviation or just a replacing name. That's it. Wherever I am supposed to use the Seaborn, I am supposed to use this SNS. That's it. Okay, and what are these matplot Seaborn? What are these things? These are just a tool in Python language in order to make a graph from your raw data. Simple. Okay, so let's try to like draw the graph of histogram. Okay, I know that you might have aware about what is histogram. So just like you need to call from SNS, just call, because these function have already written. Okay, someone has written this function, we just need to call as a data science practitioners. Okay, so what I'm supposed to do is that I'm supposed to call SNS dot histogram plot, and then if you want to see the histogram of glucose, like the glucose column, we can just run it and we can see this. See, it will just take 1 or 2 seconds. It will just try to run it and we can actually see the graph. See, this is the graph plot of histogram, okay, of the glucose column. Okay, which means that this is my glucose column, these are my data, I will be plotting this a histogram out of it. Similarly, if I wanted to plot this box plot, we can actually plot it. Okay, so let's say let's plot the box plot graph of BMI. What is box plot? So box plot will help us or guide us to see that wherever there is an outlier in the data. Now I am actually using the word outlier, right? What is outlier? Outlier means like the data which is out of the scope. Okay, let's say that you have a number from 1 to 10, okay, and you have maximum number present in between 1 to 10. But suppose if someone comes and see that there is a 1000 number, okay, so these numbers are outlier because these numbers are not frequently used in the range of 1 to 10. Okay, so that is why these are outliers. Similarly, box plot helps us to see whether there is a outlier present in the data or not. Simple. Okay, so you can see that in the BMI, see, if I go to this BMI, you can see lot of data, right? So somewhere, let's say if I just explicitly write 400, okay, so 400 would be outlier because all the data is kind of ranging between 30 to 50, in between 30 to 50, and if it contains 400, it means that 400 is outlier, right? So this box plot helps us to find out the outlier. Similarly, if you want to find out the relationship between that, you can actually able to find out the relationship also. See, so let's say that if I just want to find out the relationship between BMI and glucose. Okay, that what is the relationship between BMI and glucose? You can actually see and plot this graph as well, right? So let's say that those person who has the BMI ranging between, let's say, 0 to 200 has the glucose, let's say BMI ranging between 30 to 40 has a glucose level lying between around 0 to 200. Okay, in this way you can actually like try to visualize a lot of data. Let's say that if I want to see age, right? If I want to see age, so I can actually like see this very generic distribution, right? It looks like we can actually draw so many case study from it, right? Similarly, this is the heat map. What is heat map? So from sns.heatmap, you can actually able to find out the correlation between each column. What is correlation? So let's say there are many column, right? So if you wanted to find out that how this glucose is related to BMI, how this skin thickness is related to insulin, okay? So from this you can actually able to find out the correlationship graph between this, right? You can see that glucose is kind of correlated with the skin thickness, which means that those person who has a more skin thickness, so it is assumed from this data representation that they may have a possibility that they may have a very high glucose level or a blood sugar level. Okay, in this way you would able to see this correlation graph as well, right? All from the SNS graph, right? So this is what I wanted to show you. Okay, again, what we have done till now. So we have learned about pandas, okay, from the Python libraries. Then we have learned about the NumPy, okay, like where we are supposed to use this NumPy. And then we have learned about this data representation part, okay. These things are more than enough when we proceed our the implementation part of our linear regression model, which we have done it before. Okay, we will be following all these 9 golden rules. Thank you.